Okay, this is Mr. Pilot's lesson on heats of reaction and carbon footprint. So we've got a question here. Compare methanol and ethanol in terms of enthalpy per kilogram of CO2 using the heats of formation for the combustion reaction. So what we're trying to do is find the ideal fuel that will give us the most amount of energy for every kilogram of pollution of CO2 that we produce. And you're going to see a lot more of this type of chemistry, especially if you go into environmental studies and things like that. So first, whenever we do a question like this, our first job is to identify what our combustion reactions are going to look like. So we're going to do that right now. So our first one we're going to take a look at is methanol. So this is methanol, CH3OH, and it's any combustion reaction always involves it reacting with oxygen. And we're assuming that there's complete combustion, and we're producing carbon dioxide gas and water gas. And that's really important that you realize that the water produced is vapor and not a liquid. It will liquefy later. It'll condense and liquefy, but in this reaction it's water and the gas. Our other reaction is, and we can set that one up too right away, is ethanol reacting to produce, again, the same things. Now what's really important is that we balance the equations, but super important, and I can't stress this enough, notice that there is no number, no coefficient in front of the fuel, and that's super important. We want to make sure that there's always a 1, or we leave it blank, and never have a 2 in front of there. Otherwise what's going to happen is we're going to have to divide by 2 at a key stage along the way, and that will be forgotten. And whenever we find the heat of reaction using the heats of formation, it's best if our fuel is always a 1 mole. We're always dealing with 1 mole of the fuel, because in the end the heat of reaction is kilojoules per mole. So what I'm going to do now is just scroll down and show you what I put together. So remember that when we're dealing with heats of formation, Hess's law, we take the sum of the heats of formation of the products, and we subtract from that the heats of formation of the reactants. And so I just showed what that would look like. So we only have 1 mole of CO2, but we have 2 moles of H2O, hence 2 times the heat of formation of H2O, and 1 mole of methanol. Okay, and here's all the work there, and you can see what I did was I used in the textbook, we use the table of values, the heats of formation, which is on page 799 and 800. So this is a value for carbon dioxide, this is the value for water. I multiplied where appropriate, and that's the heat of formation of methanol. Notice I put a -0 here. Really important to remember, there's no values for heat of formation of elements if they're in their normal state at standard temperature. So oxygen at standard temperature, 25 degrees Celsius to 298 Kelvin, is a gas. There's some exceptions to this. Say a diamond actually does have a heat of formation, but graphite does not when it comes to carbon. So anyways, I do my arithmetic and I get a simple answer here, 638 kilojoules per mole. That would be the heat of reaction to burn off 1 mole of methanol, producing the subsequent carbon dioxide and water. And I'll show you that we did the same thing over here with ethanol. So again, I set this up. Now notice that my ratios are definitely different. So I have 2 moles of CO2 produced for every 1 mole of ethanol, and that's going to be important in a little bit. And I have 3 moles of water produced. I did the appropriate arithmetic there. And so I get the following values. Again, pretty similar to what we've seen for methanol. And then I come to my answer right there. So about twice the amount of energy. my next step is to look at the molar ratios. I want to compare my molar ratios of my fuel to my carbon dioxide, because if I know my molar ratios, then I can easily figure out the mass of my carbon dioxide produced. So my molar ratio of carbon dioxide to methanol is a 1-to-1 ratio. So that means that for every mole of methanol I burn, I produce 1 mole of carbon dioxide. So now my next logical step is, well, what's my molar mass of CO2? And my molar mass of CO2 is 44 grams per mole, rounded. So now that I know my number of moles, 1 mole, and my molar mass, I could figure out what my mass would be. Now what we have to do here is make sure that we convert our mass to kilograms, because that's what the question's asking. Enthalpy per kilogram CO2, not gram per CO2. So 44 grams times 1 mole, that would give 1 mole times 44 grams per mole would give me 44 grams. I multiply that though by 1 kilogram over 1,000 grams to convert it to kilograms, so I would get 0.044 kilograms. So now I need to look at my ratio between my energy, heat of reaction, and my mass of CO2 produced. So I get 638 kilojoules of energy for 0.044 kilograms of CO2. I want to know how much energy I would get if I produced 1 kilogram, so that's why I'm dividing here. And I get the following answer: 14,500 kilojoules of energy for every kilogram of CO2 I produce. So now we're going to go back and we're going to look at what happened here with ethanol. So again, I do the same thing. I look at my ratio of ethanol to CO2. Now it's a 1-to-2 ratio. So 1 mole of ethanol produces 2 moles of CO2. My molar mass of CO2 hasn't changed. That's 44 grams per mole. And so now I need to figure out my mass of CO2. In this case, it would be 44 grams times 2. Then again, I would have to convert that to kilograms. So I get 0.088 kilograms of CO2 produced if I burn 1 mole of my fuel, my ethanol. Now, to get my ratio, again, it's heat of reaction per kilogram of CO2. So I do the same thing I did on the other side. I take my heat of reaction and I divide it by the mass to set that mass to kilograms. And if you notice, there's not much of a difference. There's only 13.6 kilojoule difference between methanol and ethanol. So I get a little bit more energy from ethanol, but still not a lot in terms of difference between methanol. And there you go. That's how you would tackle a question like this.